Hello everyone, welcome to the first session of multiple integral. This multiple integral extend the concept of definite integral to the function of more than one variable. So you should know the concept of the definite integral. Not only that, we require few prerequisite formulae. So in this session, in the session number 1, just we are going to focus on the prerequisite formulas of multiple integration. So these first 11 formulae are the most important formulae for solving the numericals mainly. So integration you already learned in 11th or the 12th standard, and these formulas you should able to recall it. So the first formula that we require is integral of e raised to ax dx. Okay, integral of exponential function, and the answer is e raised to ax upon a plus c. That is the integral. Second formula is integral of x raised to n dx. And obviously, the integration of algebraic function is x raised to n plus 1 upon n plus 1 plus constant of integration is c. Remember, this formula number 2 is one of the most important formula. Roughly 60% examples of multiple integral you are able to do with this formula. Okay, and 10 to 20% example you can do with the first formula. So these two are one of the most important formulas in multiple integral numericals mainly. Third, integral of 1 by x. Integral of 1 by x is log of x. That's the third formula. And another important thing I will tell you, do not confuse with the formula of derivative and integration. Whenever you have tried down the integral of e raised to x, should write e raised to x upon a. Few of the students have a casual approach and without thinking they write e raised to ax into a. So into a comes in a differentiation, that is because of the chain rule, but here there is no chain rule, so always we divide. Okay, and 1 by x integration is a log x. That is another important formula. Integral of uv dx. This formula is known as integration by parts. It is an integration by parts where the first function u is selected by eyelet rule. Okay, this is a eyelet rule. This is a rule that we use to select the function u. Remember, generally we have algebraic and exponential function. So algebraic will be the first function and v will be the exponential. Okay, u will be the algebraic in that case. So integration by parts, the rule says first function into integral of second minus integration of derivative of first into integral of second. So you can remember like this: first into integral of second minus integral derivative of first into integral of second. That is the integration by parts. Fifth formula, integral of log x. Actually, this is not a formula. This is an example of a by parts only. But yes, you can remember like a formula. You can directly write their integration. We can evaluate this integration log x by taking u as a log x and v as a 1. Okay, and you can evaluate it as x log x minus x plus c. That is a set of the first 5 formula. Out of that, first 2 are the most important. Okay, whenever you have free time, remember, just focus on this left hand sides only and try to recall these formulas. Unless you will not able to recall it, you cannot correlate in the numericals and you cannot able to use that formula. Okay, so that about first 5. Let me move to the next. Now the sixth is not a formula, it is a method of integration. So can you guess what is the method of integration? Yes, the method is, it is a substitution method. Whenever fx and f dash x, whenever some function fx and its derivative both present in the integrand, it is a method of substitution. So we can put fx equal to t and say f dash x dx is dt. So this integral will become dt by t. Integral of dt by t is a log t, that is log of fx. So this is the answer. So integral of f dash x upon fx is a log fx, that you should remember. Next, integral of fx raised to n into f dash x dx. Same thing, you will observe fx is present, f dash x is also present. So this is the substitution. So it will become t raised to n dt. Integral of t raised to n is a t raised to n plus 1 upon n plus 1. So it will be a formula. F of x raised to n plus 1 upon n plus 1. So this is actually a method, and you have to always focus in the integrand whether both fx and f dash x both appears in the integrand. If both appears, you can do it by substitution method. Now, which are the real integrals which comes across when you evaluate these integrals, multiple integral? So this type of the numerical you will come across: integral of sine square theta cos theta d theta. Now just see the observation: sine theta is there, its a derivative of cos theta is also there. So this can be done by replacing, let sine theta is a t, let let sine theta is a t. So obviously that cos theta d theta is a dt. So the integral becomes t square dt, and the integration of t square dt is a t cube by 3. It's a t cube by 3 plus c, and we'll resubstitute the value of t. T is a sine theta, so it is a sine cube theta upon 3 plus c. So this is the way you have to do it. This is the integral of sine square theta cos theta d theta. And where is the observation? The observation is sine theta and its a derivative cos theta d theta is a present there. So this is the way we can see the substitution method. I will show you one more example. This is one more important integral we'll come across while solving the example. Integral of e raised to minus x square into x dx. Now, many of the students think about by parts here because they think x into exponential is there. Yes, you can use a by part provided e raised to linear power term is there. Here e raised to minus x square is there. So this doesn't uh, allow us to use a by parts. Here, yes, that x square only we have to take it as a t. So let x square is a t. So 2x dx, 2x dx is a dt. When we differentiate both side, derivative of x square is a 2x into dx is equal to dt. So indirectly, the value of x dx, we can write it as dt by 2. So the integral will become e raised to minus t, dt by 2. This is the integral we get. 1 by 2 is a constant as it is. Integral of e raised to minus t is a e raised to minus t upon minus 1. That is a formula number 1 only that we seen. And we resubstitute the value of t here. So minus 1 by 2 e raised to minus x square plus c, that is the integral. Okay, so these are the two important integrals that will come in the multiple integral numericals, and you have to, that time you should correlate. This is the substitution method. This is a substitution method that you have to use it there. So that about the formula number 6 and 7, substitution method. Now we'll move to the next set of the formula. So next 5 formulas here. So this is the formula: integral of 1 upon x square plus a square dx. Okay, 1 upon x square plus a square. Whenever x square plus a square is there, the formula is 1 by a tan inverse of x by a plus c. Another important thing, remember these prerequisite formulas are not only for multiple integral. I will tell you that same formulas will become a prerequisite for higher mathematics when you study in the next semester, probably the Fourier series, Laplace transform, differential equation. Many of the places you require these formulas there, same formulas. So same formulas are very important for the prerequisite of different topics there. So this is one of the formula which requires in Laplace there. Another formula, 1 upon root of x square plus a square. Whenever denominator is with square root of x square plus a square, remember the integration in terms of a log there. So the formula is a log of x plus root of x square plus a square plus c. By default, the modulus sign is always there for logarithmic function because log is a positive domain function. If you write it modulus, that's okay. If you write a bracket, that is also okay, because yes, even though you not mention the bracket, it is a positive domain function only. Okay, log exists only for positive number. That about the formula 9. Come to the next. Integral of 1 upon root of a square minus x square. Now remember this term. Whenever there is a negative sign in between a square and x square, always sine inverse comes there. So 1 upon root of a square minus x square dx, the integration is sine inverse of x by a plus c. Okay, and one more formula with root of a square minus x square. Now it is in the numerator. And I will tell you this formula number 11 is one of the most important formula. Many examples, wherever the example or wherever we do the double integration on the circular region, it may be the circle or part of the circle, we use this formula. This formula generally we require for the double integration over a circular region. And the formula goes like this: x by 2 root of s square minus x square plus a square by 2 sine inverse of x by a. So this is the one important formula that we have. And here is a last formula on this slide: integral of e raised to ax sine bx dx. This formula may be new to you, but this formula can be derived by integration by parts only. You have to apply integration by part 2 times and simplify. You will get this formula. Hardly we require this formula in one example only. So formula is e raised to ax upon a square plus b square a sine bx minus b cos bx plus c. So that about the 12 formulas. And now very simple small prerequisite that we left. We'll continue here. And this is one more important formula we require in multiple integral. As I told in the beginning, multiple integral extends the concept of this definite integral for function of multivariable. We require every time to evaluate the definite integral. And how to evaluate definite integral? So whenever integral is from a to b fx dx, and we know their integration is a g of x, just we put upper limit in that function gx minus the lower limit. So we should say g of b minus g of a. This is the way we evaluate. So integral of a to b fx dx is a g of b minus g of a. So this is the way we evaluate the definite integral. Just remember upper limit minus lower limit in the integral. When we evaluate complete integral, then we should replace upper limit minus lower limit. And the last part, many of the places where we require the values of see, you should know the value of the number e first. E is a transcendental number, just like the number pi. Number pi is a 3.14. In the same way, E is a 2.71. Nowhere you have to replace these values. Remember, nowhere you have to replace the value of E as a 2.71. It is just for your information. Just like the value of pi is there, 3.14. You can write your answer in terms of a pi. You can write your answer in terms of a E. Okay, no need to replace their values. But this value you require. When you put upper limit and lower limit, many times you will come across e raised to 0, and rarely you will come across e raised to minus infinity. So e raised to 0, anything raised to 0 is 1. So 2.71 raised to 0 is also 1. So this is the answer. E raised to 0 is a 1. E raised to infinity. Remember, e raised to infinity means 2.71 raised to infinity. You are multiplying 2.71 infinite times. Obviously, it is infinity then, not defined. But e raised to minus infinity, now you will divide a very big number, so it will be 0. Only this e raised to 0 is a value which is important, that you require, e raised to 0, and this definite. So that about a prerequisite formulae, that about our session number 1. In the next session, I'm going to explain about introduction to the multiple integral or introduction to the double integral, and then we'll see how to evaluate the type 1 problems of double integral. Okay, thank you so much. Bye.